Alright everybody, this is my YouTube video on how to assemble the RC car that got a lot of traction on Reddit. So don't have a very good camera or tripod setup, so try to do my best and keep everything in frame. So reprinted everything for the drivetrain in 100% infill, just because every 5 minutes with the brushless I was breaking something. It's getting a little bit annoying, but the thing is very fast. Took a crash once and survived. So start with the rear differential. Already got the sun gears threaded and bolted together, so these are just the STLs provided, but they're just through bolted, and then M3 doesn't really matter how far through. And then I've got the diff spacers, which are just also through bolted with the drive gear, which connects the idler and then to the motor. So first thing is we want to install the drive shafts, inboard drive shafts, and I think the key to this whole thing has been it hasn't blown up on me because I've been using a lot of petroleum jelly as the lubricant between the gears, and it seems to work real well. So give that a good amount. I put it on everything. All the gears get a good amount of petroleum jelly. It gets a little messy, but seems to work really well. So lube up that gear, and also there's no bearing between the inboard shaft and the drive gear or diff body, which it's actually riding on. So you want to lube that up, then just push it in through the gears. It'll go. You got two sets of gears that got a mesh, so but it'll go. There we go. And push that through. Might need something to help it. There we go. So that spins. Once we've got that, we have the diff plate, which is just the back side. It's essentially like the gear, but no gear. So we add in the next drive shaft. Pretty simple, same process. Left a lot of slop on these gears so that it's easy to print. They go together. You get some backlash, but it's an RC car, so who cares? So the way I do this goes in with the diff body. Once again, these are all M3 screws. You just get a big old box of them for 10 bucks on Amazon, shipped to Prime. And I did that with also the 3S battery and the speed controller, transmitter, ESC, all just straight off of Amazon. Not big on waiting. So this all just bolts together with some through bolts, and then take your 2.5mm wrench, screw her all together. Kind of tricky at first to get all the gears threaded and lined up, and you actually got to hold them or else they'll just spin on you. But tried to make this as easy to drop in parts, as easy to print and build. You see most surfaces are flat, or have one big flat surface so that you can line it up with the print bed. So just get these all screwed in. The way I have it is that I've got my printer dialed in, so I've got the holes a little bit undersized, and I actually cut the threads with the fastener when I screw them in. So you can also just use an M3 tap. Probably easier if you're not dialed in perfectly. Do the gears last, those give you some trouble. So these you want tight. It's a little bit oversized to allow the gears to spin inside this body thing. And then the gear ones you actually want to have a little bit loose, since that's what they're riding on. Once again, plenty of petroleum jelly. That's your that's what keeps this whole thing from melting. So I usually tighten and then back off. about a quarter turn usually works pretty well. Some of these go in easier than other. Surprisingly, these don't back out when it's spinning, so I thought it wouldn't work, but it works. So just get the last of these bolts tightened. Was really surprised to see the feedback on r/functional print. Really appreciate everybody's kind words, and also bringing up some cool or interesting feedback, like how I have my springs but no dampers, which actually when it drives you start to see some weird oscillations in the drivetrain, and that's probably from that. Never thought of that. I thought I just had something offset or spinning on a flywheel. Alright, so that's done. Now when I counter rotate, my gears spin just like they should. So now we'll start with the non-motor bulkhead, which I've already put together. It's pretty simple, just 2 A-arms. Then you've got, I think I called this the hub. It all just bolts together. But the way this works is the diff body just goes on with these rollerblade bearings. Just goes right through. My spacing was a little bit off, so I'm going to throw a washer if I can. Will it work? No, I might not have the right washer, and it doesn't matter. It's been working fine without it. This thing is so fast that I'm going to need to put slicks on it because it's borderline uncontrollable. So to lock everything into place, though, I think I call I'm not sure what I call these, but these connect here. They've both got the hex pattern to index them, and they just they also thread to be locked on. So I'll start with that, take my 2.5 mil, screw it in. This actually makes it easier to pull this, I forgot whatever I call it, U-joint, universal joint, onto the shaft. It's a kind of a tight fit. With your guys' printers, might be, might not be, but hopefully that's in frame. This is my first YouTube video like this, so probably out of frame a lot. Apologize for that. But the point of the video is to show you guys how to build this, so that's all that matters. Alright, so start by screwing the end on. The fastener is going to be what actually pulls it off. Sometimes it's hard to get them started. Alright, so that's started. I call them fasteners because my first job out of college as an engineer was in fasteners. Should probably be calling them bolts, but we called them fasteners, and I still do. Sounds fancier. So as you can see, it's a little bit, this hole is giving me some problems. I might have to countersink it. It's going to get countersinked. So if a bolt's just not going in, you can always countersink it. It might be a locating issue. Give it a little convincing. Probably should have ran the tap through these holes that are printed 100% infill. I think I get some shrink. So now I'm just going to push the part on. 1 second, there we go. So now that's locked on, screwed on, it'll pull itself together. Hopefully I don't break anything. I don't have any extras. So now it's pulling the gear back through the differential. Then once you feel that it's tight, should have a little bit of slop. That's what I was trying to fix, but Yeah, it's okay. Alright, so now we're going to build the U-joint, which is pretty simple. It's just two pieces, get this out of the way, that slide along each other. And want to keep petroleum jelly on this also. The easier it is to slide, the less friction losses you'll have. Threaded hole on the part, or on the through hole. Obviously the slot's not threaded. So get that all nice. And the way this works is the two parts go together, and then we just through bolt. This took a while to come up with. I needed a very small U-joint that was 3D printable and strong, because all the torque is being transmitted through these two things. So this is a design I came up with. It's pretty simple. There's surprisingly very little flex in it, and very little losses, so it works well. I haven't broken one yet. Usually I just break the axle when I crash it. So I'll tighten it all the way and then back it off a little bit so that it slides freely. Note to self, safety glasses at all times. Did almost lose an eye. I have a dented pair of safety glasses, so safety glasses all the time. The one time you're not wearing them is the time you're going to lose an eye. Yeah, probably should have brought the drill out for doing all these, but so it's still a little bit tight, so I'm going to back it off so that it's if you just can't get it to work, you can always do a little bit of filing, but very little flex in this U-joint. So that one's done. Do the next one real quick. Won't bore you with the specifics. Same process though. Actually, this can be done on the other side. This can be done later. Same process on the other side, exact same. So I won't show you. This exercise will be left to the reader. So now we got our U-joint. I like to put on I call these the blocks. Printed face towards the U-joint, and then bolt it together. Surprisingly, I think I've only broken maybe one or two of these guys. They're pretty strong also. I'm trying to come up with a way that I might need to use bigger bearings for the outer drive shaft, or sorry, wheel mounts. Those are usually what break, but it's easy to fix, so I don't really care. Print another one in a couple minutes. Well, an hour. So just screwing two M3s into the block, and it'll be able to rotate. That's how the U-joint works. Put both on before I bolt her all together. Just make it easy. A lot of these little things. So I'll do this side, then put the whole thing together. I won't show you the other side. It's the exact same, like I said. Hopefully you guys can hear me. It's a filming with a GoPro, an old one. Tried to tape my phone to a piece of 80/20, but it wasn't working too well, so this will have to do. Alright, want to leave those a little loose so that they can work their magic, but that's complete. So start by, this is the shock mount that I use. I recommend just going to the hobby store, because these are kind of a pain in the ass. You got to find the right springs. By the time I've got a bunch of springs sitting around, but if you don't, you might as well just go to the hobby store or Amazon and buy some RC shocks. Save you a lot of time. So on brushless, this thing is kind of sketchy, but running it with a Traxxas, I'll show you the motor, like a 15T or whatever it is, really fun. It's still fast. Never break any parts. But that's no fun. Gotta go as fast as you can. That's the wrong fastener. Nope, right one. So don't be, I wouldn't be worried to think that, you know, if you have a printer that's not too accurate, that's going to be difficult to print. I'm printing on a printer I actually kind of just cobbled together myself, and it's all over the place in terms of accuracy or repeatability. So I printed everything with huge tolerances, or designed everything with huge tolerances. If you can print, you know, if you got a 8-inch print bed roughly, and you can print a 45-degree overhang, you should be okay to print everything here. I used about half a spool on this, including mess up parts. Kind of got lazy and didn't, so I'm just bolting the whole thing together, the block to the U-joint that connects to the differential. Sometimes the holes that I'm threading into are a little bit small, but I don't think that's a bad thing, just a little bit tricky. So I want to keep that loose, so that's done. So as you can see, it moves all around, so it's starting to come together. I usually just use a drill, it's faster, but probably wouldn't be able to hear over it. So now we have our inboard U-joint. Hook up the outer shaft. These usually break, but now it's at 100% infill. Hopefully it's a little better. So just goes like that. And then we bolt it. Put the wheel on first. So I use these spacers that come with roller skate bearings just to push the wheels out a little bit. And then these are the 3D printed rims that just screw together. Sometimes they're finicky. Hopefully I'm in shot. But threaded, and then it's also got the hex pattern. The hex hub keeps the wheels from spinning, so you don't have to glue them. When you're replacing parts, super glue is just the bane of your existence. You end up breaking more stuff. So instead of gluing, just add the hex. It's kind of my way of doing a key. It's easier than keying something with a 3D printer. So just trying to get this bolt going. Just pop it together first. So pop right into each other. Take a little bit of finessing. There we go. Then you bolt on the, or screw in the screw. And these are all screws because they don't have a, it's been a while. They don't have the flat or the smooth part. It's fully threaded, so that's what makes it a screw. A bolt would have a shank. That's what it is. Bolts have a shank. So fully threaded socket head cap screws, M3, various lengths. Doesn't really matter. Headphone users, sorry. I won't say where I work now, but that might give away too much information. So now we just hook up the other side of the U-joint just like before. Get that finagled in there. I do this first because it gets a little bit close once you start bolting everything together. You can't flip it around as much. Probably easier not to have the top wishbone on, but as is life. got some other projects that I'm working on. I could also do build videos for if there's interest. But I'd like to see what people come up with in terms of how fast they can get this design going. Like race cars, so let's get these things going way faster than they should be. Come on. It's always the last one. I've got the motor bulkhead kind of put together already, but it's pretty simple. No moving parts, so I can just show where everything bolts together. Alright, so now we've got our rear end. We just bolt or screw the A-arm back together. I think I got everything. Actually, on my last run, I did crash it. Went up a I don't have vertical curbs. I kind of have the rounded ones, and it went right up it. It scraped the front of it, but no damage. Couldn't believe it. So that was great to see. I was expecting another week of printing or something. And these A-arms are so thin because I want them to break and take away some of the energy in a crash. I haven't broken one yet, but that's the plan. So now we've got our right wheel assembly. A little bit loose on the wheel. I have to take a look at why that is, but that's just a matter of tightening it. So put this aside for the second, and this is the motor bulkhead. I've got the little 10-tooth gear inside here. I can point at it. That just slips on the motor. I included another gear that people can play with if they have different size shafts. This gear is actually held with a spacer built into the, oh, it's just, I think, a 100thou spacer. I think I named it that. This is just an M4 screw that kind of centers this bearing real nice. So you can use any sort of screw or bolt that's going to center this, as long as it's an M4 thread, because it through bolts. And that's the way of fastening this. There's a lot of force on it, so. Then the motor's just got 2 studs. You can use a bolt also, but I just had these laying around. And then there's the motor spacer. That sets the distance for everything. Then these are just the, I forgot what I called them, but it's obvious to see from the STL visualizer. These just set the distance for the frame and the differential. Kind of holds the differential. And then obviously same exact process on the back side. So we'll go and bolt this thing up. So the way this works is just slides in together real nice and easy. Then you've got your locate your bolt holes. Make sure I'm not forgetting anything. And I'm going to be able to put in the, even though this is all put together, I'll still be able to put the other U-joint and everything in. You can access it by just taking off the top A-arm. Just half the top A-arm. I don't keep these too tight. Really no reason to. It's PLA, you're just going to strip it out anyways. Yeah. A little bit bowed. So really didn't think about, I've got the drive gear as the lowest part of the middle of the frame, which you don't want it to be. So I did actually, there's a clip-on skid plate that goes on. I'll show that in a second. That's important. So it's starting to look like a rear end now. So I don't put the gears on, or the, springs on until the end. Makes it easier to push the assembly out of the way. Fortunately, I don't have an assembly for this build in SolidWorks. You kind of get tired of building assemblies, so I just kind of did it from memory, remembered where all my, and then just looked back at previous parts and did some references. But, all right, so now we've got the back end half put together, but do the other half later. And then what we do is move these so I don't lose them. We bolt it to the rest of the frame, which is just with these 4 bolts. So I'll do that real quick. I'm going to do another video for the front steering assembly. It's a little bit simpler, but I didn't want to make this video too long. I think I'm coming up on probably a half hour. What am I on? 25 minutes, 26 minutes. So there's just 4 holes. These bolt in. Everything's pretty accessible. I think I missed a bolt on the other. No, I'm good. Nothing worse than having to dig through a bunch of parts and break stuff that's... Alright, where's the... There it is. So I'll just screw this together. Motor and the speed controller together, I think they were $47. LiPo was about 20 bucks. Servo, just a standard, was it 55 gram servo? It's about 10 bucks. I 3D printed the back rims, but the front rims, and I'll get to that when I do a video on that, but is it gonna thread? I just left them because I didn't need to modify them. No reason to waste plastic. This is my first screw up. So the back rims are 3D printed, front rims are came with the tires. I'll link the tires, they were like 10 bucks. What was I talking about? Also the receiver transmitter, the cheapest one I could find because I don't really care about features on it. I just need 2 channels. It was like 15 bucks on Amazon. I'm gonna link all the prices so that way. And it was all Prime one day because I have no patience. I'm spoiled. It's the only thing I use my Amazon for is buying weird Chinese components that I can build stuff with. And Arduinos. Jeez, oh Pete. Too many Arduinos. So I'm gonna bolt the back side so I don't screw anything up. This is usually the easiest part. Might have to get the drill out. It's also kind of tricky keeping everything in frame. I do run a voltage meter. I guess it also, and that's how I can tell when I'm getting low on battery. It's actually a quadcopter battery, but just don't crash. The lighter's always better. Bonus points, anybody can tell me why there's 2 switches here. I've only got 2 wires, so unless they got different resistances and there's some magic going on in the speed controller, why did they give me 2 switches on that? But who knows? They both do the same thing, apparently, unless I'm wrong. So this thing's pretty much done. Just gotta bolt the, or locate the, should have left it a little bit loose. It's always the last one. There we go. These fasteners probably don't need to be this long, but I added them just for fun. Luckily got a little time because making a new account on Thingiverse, gotta wait 24 hours to post your first item, so gives me time to make the video get to keep to my Saturday promise. A lot of people using the Remind Me bot for a week or a month, but keeping my promise. Hopefully this helps somebody enjoy the hobby like it has myself. Always been into RC cars, got into quadcopters, but it's a heck of a lot more fun if you can make your own. Heck of a lot better than nitro, that's for sure. Don't have to have blisters on between my fingers trying to get the damn thing to start. 07 frame. Bumped the camera a couple times, I think. Alright, so that's together. Pretty painless. So now what we'll do is we'll add the clip-on guard. Just goes on the edge. And this is just to protect. Kind of tricky to get on. Obviously made the holes a little undersized on purpose, or the clips. Just clips on. That's my guard. Obviously it's working because it's got some scratches under it. So that's the rear end. Obviously hook up your motor. I'll do the front end hopefully tomorrow. That way you can have the whole build complete. Am I doing these out of order? Don't want them crossing. Just for aesthetics. So everything's got a fillet on it. You gotta have the aesthetics. Alright, that's it everybody. Hope you like this video. Hopefully you get to enjoy this thing like I did. I like it when other people get to enjoy my designs, obviously. You know, race it to the edge, break it. Let's come up with some ways to make it better. So be ready for a front end video also. It's pretty simple though. So tune in for that. Bye.